Welcome to another Titus Timeout podcast. This is Mark Costello, and today we will review perimeter applications. Perimeter windows are one of the largest loads in conditioned spaces. During the warm months, heat is transferred through the glass into the occupied space and rises to the unoccupied portion of the space. As long as we have a ceiling diffuser near the window, the cold air from the diffuser can be used to offset the window load by mixing cold air with the heated air in the space above the occupied zone. Of greater concern is the treatment of the loads generated during the cool months. Untreated cold air falls to the floor level and stratifies within the occupied zone. To offset this load, we need to mix warm air with the cold load to offset the effect in the occupied zone. Because heated supply air will rise, the most efficient way to accomplish perimeter heating is to supply air from below the floor or sill and use the natural buoyancy of the heated air to cover the perimeter window. Unfortunately, supplying cold air during the summer months from the floor will not efficiently mix the ceiling air where warm air stratifies, and split systems are just too expensive. So, the challenge historically has been how to economically and efficiently heat and cool from the same overhead system. The traditional answer has been to use linear slot diffusers that have two sets of pattern controllers. We set one half of the unit to blow air horizontally across the ceiling to offset the heat load in warm months, and the other half of the unit is set to blow air vertically down across the window surface. This is known as the 50-50 compromise. Now let's take a look at the 50-50 compromise from a plan view perspective. We'll place a 4-foot diffuser about 18 inches from the window typically. It will have two sets of 2-foot pattern controllers. One set of 2-foot pattern controllers will be set to blow towards the window, and the other towards the interior of the space. Again, this is our 50-50 compromise. And although it does work well to address both applications, we're only getting half of the air in the needed direction at any given mode. Auto changeover diffusers are not new. Old technology utilized a sealed cylinder with wax inside it that when heated pushed an actuator rod that could move a pattern controller. The pattern controllers will direct the air either towards the window or towards the interior room space. These pattern controllers were actuated by an old beeswax power pill, as they're known. These are cylindrical devices filled with wax that have a plunger that gets pushed out when the wax is heated by supply air temperature. Problem is, pattern controller swept the room with cool air on the changeover from heat mode, and actuation took long enough to use an hourglass or a sundial to measure the time it took to change. Additionally, there's a 10-degree deadband, so the room could get uncomfortable before the unit changed over. Electrically actuated units followed these beeswax actuated units and provided more precision on the deadband and faster actuation, but they required controls and electrical wiring. The new age solution is the Titus EOS slot diffuser. The EOS is solar powered, drawing power from ambient lights within the occupied space, which next to a perimeter window is easy to come by. This works very well next to the windows and no electrical connections are required. The digital control board and the micro DC servo motor within the EOS provide fast change and digital precision. The 3-degree deadband is the narrowest in the industry, and the auto changeover is nearly instantaneous. Check into EOS. It is truly the smart diffuser, and it is available only from Titus. We thank you for your investment of time in this Titus Timeout podcast and invite you to subscribe to our YouTube channel. Thanks for taking a Titus Timeout.